Now see, we already discussed this thing. Physical quantities are divided in two categories: scalar physical quantities and vector physical quantities. And scalar physical quantities are simple numbers. And what are vector physical quantities? That we already discussed. But now we have to think about the combination of these physical quantities. Combination of physical quantities, that is nothing but the algebra of physical quantities. So here we have to think about two types of algebra. Algebra for scalar physical quantities and algebra for vector physical quantities. So scalar algebra. So scalar algebra means what? So scalar algebra means the summation, subtraction, multiplication, division of scalar physical quantities. So in scalar algebra, when we think about the addition, subtraction, multiplication or division of scalar physical quantities, then it is just like our simple algebra which we study in mathematics, because scalar quantities are just numbers. So simply we can take summation, multiplication, subtraction, division of these numbers. But vector algebra, that is a special type of algebra, right? Now in vector algebra we have to discuss summation of vectors, subtraction of vectors and multiplication of vectors. Divisions of vectors are not defined. Clear? And this summation, subtraction and multiplication of vectors means it is a special type of combinations of vector physical quantities. Or in other words, we can say when two or more than two vector physical quantities are effective, are combined, then what will be the resultant effect that can be represented with the help of vector algebra. So vector algebra, that is divided in this way. In vector algebra, we have to think about the addition of vectors, subtraction of vectors and multiplication of vectors. Multiplication of vectors, that is again categorized in two categories: scalar product of vectors and vector product of vectors. When we will discuss this multiplication of vectors in detail, at that time we will discuss this scalar product and vector product in detail. Now we have to discuss first addition and subtraction of vectors. Clear?